Okay, welcome my friends. I want to start off by saying thank you for taking physics. It's one of my favorite subjects in science, and hopefully after this year you will also say it's one of your favorite subjects in science. Before I start here into this slide show, I wanted you to have something out and ready to go before we start. So these slides, everything that we talk about in this video is going to go right along with your Introduction to Physics guided notes in your student workbook. So please have your Introduction to Physics guided notes out and be filling them out as we go through these slides. Okay, so this slide right here I wanted to start with. I just put up a few pictures that remind me of physics. So a model of the atom. So even things as small as an atom has to do with physics. But also things as large as a whole galaxy here, the spiral galaxy. That's why physics is so cool to me, is it includes includes everything in the universe. And we're trying to understand how it behaves and why it behaves that way. Another couple of pictures that remind me of physics is this picture here. This is Isaac Newton, and as the story goes, he was sitting under the apple tree and the apple fell down, and maybe it hit him on the head, maybe it didn't. But he started thinking about what's making that apple fall toward the ground. And that, of course, led him into a study of gravity and how it works and quantifying gravity. And then I've got a picture down here of Albert Einstein, who took it even farther, this idea of why something falls toward the ground, and also many other things. So Isaac Newton, we're going to study in physics this year most of Isaac Newton's stuff, which is kind of classified as classical physics. We will not study Albert Einstein and what he contributed to physics very much. A little bit, but that's more advanced physics. But if you, in this introductory physics class, can understand Isaac Newton and get a good foundation for what he proposed with physics, then I think we're on the right track. So let's get started. I wanted to first start off with what physics actually means. Well, this word physics comes from the Greek language. And in Greek, it means knowledge of nature. So physics comes from the Greek language. It means knowledge of nature. Physics is the analysis of nature. So we're going to analyze nature. Conducted in order to understand how the universe behaves. So we're trying to figure out how everything in the universe behaves. Things here on Earth, but it doesn't have to be just here on Earth. It can be anywhere in the universe. Other planets in our solar system. Stars throughout the galaxy, or the whole universe for that matter. We're trying to understand how the universe behaves, and that's what makes physics really cool to me. Physics uses math to help explain how the universe behaves. Students all the time are, I guess, surprised at how much math there is in physics. So I'll just be up front with you now. We're going to be doing math every day in physics. Every day. Now the math is going to be relatively simple math. We're going to use some simple algebra. We're going to go over some simple trigonometry throughout this class. But we're going to keep the math pretty simple in this introductory physics class. So just expect to use math every day. We're going to need a scientific calculator. But a lot of students say this should be a math class. And really it probably could be. So we're just going to be using a lot of math every day. But it's good math. It's applied mathematics. It's actually math with a purpose. And hopefully you'll be able to see the benefits of using it. I really like this picture right here. This is a jigsaw puzzle of the world. And to me, this is what learning physics is about. When we learn physics this year, hopefully you're going to add some pieces to your view of how the world works. So every time we learn something new, each chapter, we're going to throw on some more pieces, and by the end, we should have a better idea of how the world works, and the universe works, for that matter. So topics that we're going to learn about this year. We're going to cover these following topics. We're going to spend the first quarter learning about motion. We're going to be able to describe motion. We're going to quantify motion, or put a number to the motion, and a lot of other things. Second quarter, we're going to really focus on these three terms: what a force is, what mass is, and what acceleration is. And we're going to combine all those and understand how each one is dependent upon the other one, and how they all interact with each other. Third quarter, we're going to study gravity and the electronic forces. Near the end of the class, we'll learn about energy, and also we'll conclude this physics course by learning about waves. So those are the 5 topics that you're going to learn about this year. So let's start. This is the Introduction to Physics notes. I wanted to put a section in to this introductory part talking about how to analyze data. We're going to be doing a lot of analyzing data, and so it's very important that we got the basics down. What I want to talk about today is some of the basics. So let's start here with a quantity. This was one of our vocab words. Quantity is something that can be quantified or given a number to. So if you can quantify something, you can put a number to it. Something that can be quantified, you can put a number to it. For example, maybe we're looking in the parking lot and you say there's 20 cars in the parking lot. Well, because you put a number to it, that's a quantity. There's a lot of things that can be quantified. Temperature, obviously. It's a really hot day. You look at the thermometer, it's 100 degrees Fahrenheit. Well, because you can put a number to it, that's a quantity. Your velocity or speed, also you can put a number to it. 65 miles per hour. Well, you put a number to it, it's a quantity. So anything you can put a number to is a quantity. A physical quantity is a physical property that can be expressed in numbers. Expressed in numbers. So if we can put a number to it, it's a physical quantity. An example is length. When we measure the length of something, we're going to put a number to it. Mass. How many grams or how many kilograms? Temperature. A lot of different scales for measuring temperature, like Celsius or Fahrenheit. But we're putting a number to it, so it's a physical quantity. In physics, we will quantify everything. Quantify everything. We want to express everything in terms of a number. And that's why there's a lot of math in physics. We always want to quantify things. So we will be working with numbers and doing math every day. Even things that you might not have thought about before can be quantified, like color. Colors, guys, can be quantified very easily. A color is basically the wavelength of light. So we're talking about numbers. Everything can be quantified. You might say that your shirt is red, but to a physicist, that's not good enough. We want to know and be able to quantify that color of red. Exactly how many wavelengths is being reflected by that color of red. Everything can be quantified. And so we're going to deal a lot with numbers. So let's move on. Let's talk about units for a second. There are two common systems of units. There's an SI unit. SI stands for System International, more commonly known as the metric system. So the SI base units are known as the metric system. An example of some units in the metric system is a meter, a kilogram, and seconds. We've heard of those before. The other common system of units is called the imperial system of units. An example of this is measuring length. We measure it in feet, or the foot. Measure weight. We do it with pounds. And time, of course, we use seconds. So these are the same. But if you look, measuring length in the metric system is a meter, and the imperial system is a foot. So there's some differences. In science, though, we're going to use the metric system. And there's a good reason for this. Scientists want to be able to communicate with other scientists throughout the world. And if we all use different units or systems of units, it would lead to some problems. So to make it easy for everyone, we don't have to convert from one system to another, all scientists use the metric system. Now, here in the United States, we don't use the metric system. We use the imperial system, which I think kind of puts students in the United States at a little bit of a disadvantage at learning science, because science is the metric system. So, I know that we're not using the metric system on a daily basis, but I wanted to go through the metric system in this introductory unit so that when we get into the physics coursework, the metric system, you just understand it and it's pretty easy. So, let's go through the metric system basics for a second. Okay, I think as we go through this, you'll realize that the metric system probably is a better system to use. It's a lot easier to convert from one unit to another, and let's see that. So the metric system is based on a base unit that corresponds to a certain kind of measurement. So the metric system is based on these base units that correspond to a certain kind of measurement. For example, in the metric system, the base unit for length is the meter. The base unit for volume is the liter. And the base unit for weight, which is really mass, is the gram. So the meter, the liter, and the gram are the base units in the metric system. The metric system also has what we call prefixes. Prefixes mean it comes before the word. So prefixes plus base units make up the metric system. So we've got these prefixes which come before the word. Then we've got the base units. That's what's going to make up the metric system. For example, centa comes before, so it's a prefix. So centa, and then our base unit here is the meter. Well, if we combine those two, it makes up the centimeter. We can do the same thing for a prefix called kilo. The base unit is a liter, so we're measuring volume. Well, a kiloliter. These prefixes are based on powers of 10. So centa and kilo, these are prefixes, and they are based on powers of 10. And that's what makes the metric system so useful, is because they're based on powers of 10, it makes it very easy to convert from one unit to another, one prefix to another. And I'll show you that coming up. So the three prefixes that we will use the most in the metric system are kilo, centa, and milli. These are the three that we really have to know. We're going to be using these prefixes the most. So kilo, centa, and milli. The base units in the metric system are meter, liter, and gram. So these are the base units. When we're measuring length, we're doing it in the meter. When we're measuring volume, we're doing it in liters. And when we're measuring mass, we're measuring in terms of grams. So, in the metric system, we're going to see in the center box the base units. It's the meter, the gram, and the liter. These are the 3 base units. Alright, so I've got a mnemonic, and what a mnemonic is an easy way of remembering the order of something. This mnemonic is for the metric system. So even though we will usually only use the prefixes kilo, centa, and milli, it's a good idea to remember all of the prefixes in the metric system. So here's a way to remember all of the different prefixes in the metric system. In order, too. So the following mnemonic will help you remember all the prefixes in order, and it's very easy. Okay, so here's the mnemonic. Killer hippos die by drinking chunky milk. Killer hippos died by drinking chunky milk. And if you look at the first letter of each one of these words, so for killer it's K, hippos is H, die is D, by is B, drinking is D, chunky is C, and milk is M. That first letter means something. It's the prefixes in the metric system. So, example, it says to fill in all the prefixes of the metric system. So I want you to draw this, or it's probably drawn in your guided notes. So we've got, how many boxes here? 1, 2, 3, 4, 5, 6, 7. I want you to draw a big long rectangle and divide it into 7 boxes. And here's why. Okay? In this first box, we're going to put K. In the second box over, we're going to write the H from hippos. So killer, hippos. The next one is die, so we're going to put a D. By is B. Drinking is D. It's a D, lowercase on this side. Chunky is C, and milk is M. Okay, and that's an easy way of remembering the prefixes in the metric system in order. This K is for kilo. H is for hecto. The capital D is for deca. The B is for base. This is our base units. The D is for deci. Lowercase d is for deci. C is for centa. M is for milli. Okay, and so if you remember that mnemonic, killer hippos die by drinking chunky milk, you can remember all of the prefixes in the metric system in order. And I recommend just drawing out those boxes. Well, what if you forget how many boxes? Well, just go back to the mnemonic. Killer hippos die by drinking chunky milk. So there's got to be 7 boxes there. And then just throw in the first letter and you have it. So the metric system, each prefix is based on powers of 10. So it's the prefix that's based on powers of 10, and it's easy to convert from one prefix to another prefix in the metric system. From each prefix, every step is either 10 times larger or 10 times smaller. For example, let's look here at centa. Let's talk about meters. So centimeters. Like it says here, centimeters are 10 times larger than millimeters. So notice milli is right here. So as we move this way, we're getting 10 times larger. One centimeter then is 10 millimeters. 1 centimeter is 10 millimeters. And you see that on a ruler. So here's a ruler. These numbers right here are centimeters. And the little lines in between are millimeters. So you'll notice that there has to be 10 millimeters is equal to 1 centimeter. And notice, it's based on powers of 10. And that's what makes the metric system so useful. Okay, for each step to the right, we're going to multiply by 10. So if we go to the right on this chart, we're going to multiply our number by 10. For each step to the left, so if we now go to the left, we're going to divide by 10. This means that you can simply count the number of boxes that you move, either to the right or to the left, and move the decimal that many times. So for example, if we move 3 boxes to the right, we're going to move the decimal 1, 2, 3 boxes to the right. So here's an example problem. And here's a question that you're going to get a lot in physics. You're going to be expected to go from one prefix to another prefix in the metric system. So this says how many kilometers are in 5,000 meters. So first thing I would do is draw your boxes. Okay, so we've got this drawn. And next thing I would do is we know that there's 7. So let's divide it into 7 boxes. Okay. Now remember the mnemonic. Killer, hippos, die. This is our base unit box. By drinking chunky milk. Now what I do is we want to know how many kilometers are in 5,000 meters. So we're starting with 5,000 meters. So we're starting here, meters. So where does it say meters at in our chart down here? Well, you'll notice meter is a base unit. Meter, liter, and gram are base units. So we're starting right here in this base box. Now we want to know how many kilometers are in 5,000 meters. So we're trying to go to the kilo box. Which one is the kilo box? Well, it's this one. Okay, so we're starting here. We're going to go 1, 2, 3 boxes to the left. So look how easy this is. All you have to do, in 5,000, there's an understood decimal right there. So we're going to move that decimal, the number of spaces or the number of boxes that you moved, and in the direction that you moved. So we moved 1, 2, 3 boxes. So we're going to move our decimal 1, 2, 3 spots. And so now it becomes 5. And the decimal will be right here. 5 what? Well, 5 kilometers. So in 5,000 meters, that's 5 kilometers. So it's very easy, and that's what makes the metric system so useful. Remember, figure out where you're starting from, find it on the box diagram, count how many boxes you need to move in either direction, and that's the way and the number of times you move the decimal. Okay, so metric system made easy. If you move to the left in the diagram, move the decimal to the left. So just like in that previous example, we went 3 to the left. So move the decimal 3 to the left. However, if you move to the right in the diagram, you're going to move the decimal to the right. So sometimes we're going to go from meter to millimeters. Well, you would just move it 1, 2, 3 decimal places to the right. So it's very easy. If you go left, move the decimal left. If you go to the right, move the decimal right. Okay, practice problem number 1. It says, using the mnemonic to remember the prefixes, draw the boxes for the metric system and answer the following question. 1 meter is equal to how many centimeters? So let's use that mnemonic. Killer hippos die by, and for by, let's just write base. Let's get in the habit of writing base for by. It's right in the middle. It's easy to remember. That's our base. So killer hippos died by drinking. Everything on the right side of the base is lowercase. Drinking chunky milk. All right. So now let's look at what we have. Okay, we're starting with 1 meter. That's our quantity. So look at your quantity. That's where you're starting at. Meters. Well, guess what? Meters isn't on this, is it? It's not on our diagram. This is killer hippos die by drinking chunky milk. This M is for milli. So you got to remember the base units in the metric system are the meter, the liter, and the gram. So these 3 units here go in the base unit box. So we're starting right here at the base unit, at meters. And we want to go to centa. So which box means centa? Well, that's the C. So let's count how many boxes we need to move and in which direction. 1, 2. And that ends up in the C, in the centa box. So what are we going to do with our decimal? We're going to move it 1, 2 to the right. Well, 1 has an understood decimal right here. We move it 2 spots to the right, 1, 2, and now the decimal's here. That becomes 100. And so there's my answer, 100 centimeters. See how easy that is? I hope that you guys are seeing how easy the metric system can be. And you can't do this using the imperial system. If I asked you, to convert from feet to inches, it wouldn't be as simple as just moving the decimal. And so the metric system really is useful because of that. All right, let's try a few more of these. Practice problem number 2. Using the mnemonic to remember the prefixes in the metric system, draw the boxes for the metric system and answer the following question. 1,000 millimeters is equal to how many centimeters? Okay, so hopefully you've drawn your boxes here. Remember, draw a big rectangle. That's what I always do. And I just remember that there's 7 of them, so you got to divide it into 7 boxes here. And now let's just go through the mnemonic. Killer hippos die by is for the base unit box. That always goes in the middle, and that's meter, liter, and gram. They all go in there. Died by drinking chunky milk. Okay. If you can do that, the rest of the problem is a piece of cake. Because we're starting, now, where are we starting at? Well, this quantity right here. That's where we're starting. 1,000 millimeters. Millibox is right here. So we're starting here, and we want to go to centa. Centa is C, so we're just going to go 1 box to the left. So what do we do with our decimal? Well, in 1,000, the understood decimal is right here. So we're going to move it 1 to the left. And now it becomes what number? 100. And so there's my answer. If you had 1,000 millimeters, that would be 100 centimeters. Okay, very easy. Hopefully you got that right. Let's go to number 3. Same thing, we're going to use the mnemonic, fill out this chart, and answer this question here. 16,093 meters is equal to how many kilometers? Okay, let's go through the mnemonic. Killer hippos die by is the base unit box. Drinking chunky milk. Now, I always like to put in the base unit box meter, liter, and gram. So I just write their symbols there. Okay, now where are we starting? We're starting with what's quantified here, 16,093 meters. So where is meters at in our diagram? Well, meter is a base unit. So we're starting here at the base unit box. I like to draw a star there if you're just learning about it. And we want to go to the kilometers box. Well, where's the kilo box? Starts with a K. Kilo is right here. So, which way do we have to go and how many boxes? We're starting here at meters. So let's go 1, 2, 3 boxes to the left. So that means we move the decimal 3 spots, decimal places to the left. So there's an understood decimal place right here. 1, 2, 3. If we put the decimal there, it's going to be 16.093. 16.093 is our answer. Very easy. Hopefully you got that right. Hopefully you're getting the hang of this by now. I've got quite a few more practice problems. So, practice problem number 4. Same thing. Fill in your diagram down here using the mnemonic and answer this question. 40,000 centimeters is equal to how many kilometers? So I want you to hit pause in your video. I want you to try this one on your own first. So please hit pause right now. And then once you have your answer, hit play and see if you got it right. Okay, so hopefully you've tried that on your own by now and you have an answer. Let's see if you got it right. So first of all, killer hippos die by drinking chunky milk. We're starting with 40,000 centimeters. Centibox is right here. And we want to know how many kilometers that is. Well, the kilo box is right here. So if we're starting over here in the centibox, we need to go 1, 2, 3, 4, 5 boxes to the left. That means we move the decimal 5 times to the left. In 40,000, the understood decimal place is right here. So let's move it 5 boxes, or 5 decimal places to the left. 1, 2, 3, 4, 5. And so when we put the decimal right there, that becomes 0.4 kilometers. All right, hopefully you got that right, and you're seeing how easy it is with the metric system. Practice problem number 5, same story. Fill out the boxes with the mnemonic, and then answer this question. 4,000 meters is equal to how many kilometers? So again, on your video, I hope that you hit pause right now. Try it on your own. Once you have your answer, hit play and see if you got it right. Okay, so I went ahead and filled out the diagram with the mnemonic, and I've got all the prefixes in the correct order. Now let's answer the question. 4,000 meters, so we're starting here in the meter box, is how many kilometers? We want to go to the kilo box, which is over here, so that's 1, 2, 3 boxes to the left. So let's move it the decimal place, which is understood right here, 3 to the left. 1, 2, 3, and that becomes 4.0 kilometers. So 4,000 meters is 4 kilometers. Hopefully you got that right. All right, good job. I've got a few more for you, just to make sure we've got this down. Practice problem number 6. 4,000 centimeters is how many meters? Again, please hit pause. Try this one on your own. Once you have your answer, hit play, see if you got it right. Okay, so let's see how you did. Hopefully you have your own answer right now, but here's how I would do this problem. We're at 4,000 centimeters. The centibox is right here, so I put a little star. We want to go to meters. Remember, meters is a base unit. So we're going to go 1, 2 boxes to the left to get to that base unit box, and there we go. So let's move the decimal. Since we went 2 boxes to the left, let's move the decimal place 2 to the left, and that becomes 40 meters. So 4,000 centimeters is 40 meters. All right, very good. Number 7. Same story here. Please fill out the prefixes in these boxes and then answer the question. 5 meters is how many centimeters? So So please hit pause on your video, get an answer on your own, then hit play, see if you got it right. Okay, let's see how you did with this one. It says 5 meters is equal to how many centimeters? Well, 5 has an understood decimal place right here, so you could write it as 5.0 if you wanted to. It looks like meters is right here, so we're going to go 2 boxes to the right to get to the centa box. So because we went 2 boxes to the right, we're now going to move the decimal 2 spots to the right, and that becomes 500. So if you have 5 meters, that is 500 centimeters. Okay, so hopefully you got that right and we're getting the hang of this. You got just a couple more practice problems. Practice problem number 8. So please try this one on your own. Again, hit pause right now. Once you have your answer, hit play and see if you got it right. Okay, let's see how you guys did. We're starting with 0.3 kilometers. So I'm going to start in this K box. This is for kilo. And it wants to know how many meters that is. Remember, meters is a base unit. It's in the base unit box. This M over here stands for milli. So don't get that confused. If it's just talking about meters, we're coming to the base unit box. So that is 1, 2, 3 boxes to the right. So sometimes I like to add some zeros and just move it. Let's see, we went 1, 2, 3 to the right, so let's move it 3 spots to the right. 1, 2, 3. And that understood decimal there now becomes 300 meters. So 0.3 kilometers is 300 meters. All right, practice problem number 9. I think this is the last one for this type of question. So again, fill out your mnemonic, use your mnemonic, fill out the boxes here of all the prefixes in the metric system. Answer this question on your own, so please hit pause right now, try it on your own, and once you have your answer, hit play. Okay, let's see how you guys did with this one. I get students all the time, even students that have had a science class for many years, they still get confused on which way to move the decimal. And so that's why I'm teaching you this method. Killer hippos die by drinking chunky milk. If you draw that out on your paper, make the boxes, you will always know which way to move the decimal. So, for example, 0.004 kilometers is equal to how many millimeters? So first of all, we need to know where we're starting. We've got 0.004 kilometers. The kilo box is right here, so this is where we start. We're trying to go to millimeters. Millibox is right here, so this is where we're going to end. So now let's just find out how many boxes we had to go in which direction. So 1, 2, 3, 4, 5, 6. We're going to move the decimal 6 places, and we're going to go to the right. So before we do that, we know we're going to go 6 to the right, so I'm just going to add some zeros to the end of this one. Now our understood decimal place, well, it is right here. We're going to go 6 decimal places to the right. So 1, 2, 3, 4, 5, 6. And if you place the decimal there, now count 1, 2, 3, and then there would be commas. Isn't that 4,000 millimeters? So 0.004 kilometers is equal to 4,000 millimeters. Okay, so hopefully that gives you a better understanding of the metric system and how to convert from one prefix in the metric system to another prefix. It's very easy because it's based on powers of 10. All right, so the metric system, let's summarize what we just talked about here. We have base units in the metric system. These base units, which we put in the base unit box, for length is the meter, for volume is the liter, and for mass is grams. So if you want to put meter, liter, gram in that box, that's what I always do. It's based on powers of 10, the metric system is. for conversions within the metric system, each step is 1 decimal place to the right or left. For example, if you went 1 to the right, that's 1 decimal place to the right. If you went 2 to the left, well, move the decimal 2 spots, 2 places to the left. So, using the diagram below, converting to the right moves the decimal to the right and vice versa. So hopefully that's a pretty good summary of the metric system. Before we stop the video today, I've got one more thing to talk about, and this is the SI base units. Remember, SI is System International, which is the metric system. I've got a table in your guided notes for all of these SI base units, and I wanted you to fill out some things. Okay, so for length in the metric system, the base unit is the meter, so you're supposed to write in meter. The abbreviation for meter is a lowercase m, so that's how you abbreviate meter. For mass in the metric system, the base unit is a gram. And we abbreviate gram with a lowercase g. Time is pretty easy. We also, in the imperial system, use seconds. We're going to abbreviate that with an s. There's other things that we can quantify as well, like electric current. The base unit is called an ampere. Capital A. Temperature is actually in a scale called the Kelvin scale. So we're going to measure temperature in Kelvin, and that's a capital K. The amount of a substance, if you've taken chemistry, we measured the amount of something with what is called a mole. And we abbreviate it with just MOL. Just leave off the E. So light intensity, or luminous intensity, is measured in a unit called candela, and it's abbreviated CD. But just realize that there's a lot of different quantities we can measure, and there's a lot of different base units, and they all have an abbreviation to them as well. Some common SI prefixes for units. You've probably seen these before. So these prefixes here, let's just go over them. Nano. So nanotechnology is something you'll hear a lot about in science now. What that means is you're dealing with really, really small things. This is 10 to the minus 9th. So, there's 9 decimal places until you get to a 1 here. This is a billionth of a meter. So when we're talking about nanotechnology, we're talking about things that are a billion times smaller than a meter. You've heard of this one, a micro, which is a million. A millionth. Milli, which we just got done learning about, is 1,000th. How I remember that is milli is like a millennium. Millennium is 1,000 years. So there's also centa, like a century. That is 100th. Deci, that's a 10. So all of these prefixes are very small. And now we're going to get to the prefixes that are going large. So up here, these ones are large. So if we had a kiloliter, well, that's 1,000 liters. There's also mega, which is a million. There's a giga, like a gigabyte, is a billion bytes. There's also a terabyte, which is a trillion bytes. And there's peta, which is a quadrillion. So those are very large prefixes. Okay, there's also SI derived quantities. So this is derived quantities. A derived unit are found by multiplying 2 base units together. We're dividing 2 base units. So example, if we were asked to find the area of a room, we would take its length times its width. Well, when you take a meter and times it by a meter, you get meter squared, and that's a derived unit because you multiplied two base units together. There are derived units with special names. Example is a Newton. We'll talk a lot about newtons in physics later on, which is a unit of force, and Pascal, which is a unit of pressure. Here's another chart that shows all the different derived quantities, like area, volume, speed and velocity, acceleration, density, force, pressure, energy, power, and all of these. Notice, derived just means we're combining a couple of base units, and that's what we're doing here. We're either timesing or dividing different base units. Okay, so I'd like to finish with this slide. Did you learn what physics is? Comes from which language? Comes from the Greek language. What does it mean? Knowledge of nature. What does quantity mean? Remember, in physics, we aim to quantify everything. It just means put a number to it. So if you can put a number to it, it can be quantified. Physics uses blank to help explain the natural world. We're going to be using math, a lot of mathematics to help explain the natural world. We're going to be doing math every day. In science, we use the blank system of units. Well, we use the metric system. We do not use the imperial system in science. The metric system is based on powers of 10, and that's what makes it so useful. We can slide the decimal either to the right or to the left. Did you learn the mnemonic for the metric system? And hopefully you're saying it to yourself. Killer hippos die by drinking chunky milk. Okay, that's it for this lesson. Before I stop the video, please, I want you to go in your student workbook. There's a worksheet titled Metric System Conversion Worksheet. So please go there now and let's get that done. Again, it's called the Metric System Conversion Worksheet, and you should be able to do that after watching this video. And hopefully this helped.